So in this video, we're going to be going over how to or we're going to be going over how to actually draw the unit circle and basically I'm going to explain the unit circle and how it relates to the 6 basic trig functions. So starting off, I drew a simple unit circle right here, and we have the key values. So the key values you have to understand for the unit circle are 0, pi over 6, pi over 4, pi over 3, and pi over 2. These are the 6 key points that you should know when you're drawing a unit circle or even writing a table of values. Starting off, when we're looking at a unit circle, the unit circle always has a radius of 1. It has a center of 0, 0. So the radius is right here. This right here is the radius of this unit circle, and it extends in all 4 directions towards the negative side of the x-axis, the negative side of the y-axis, the positive side of the y-axis, and the positive side of the x-axis. So it extends out at a radius of 1, and it has a center of 0, 0. So that's where everything starts from, 0. And the key values, I split up I'm focusing more on the first quadrant, because this first quadrant can basically build the foundation of the values for the sine and cosine, and you can apply those to other quadrants as well. When you have, say, a negative angle or something like that, you can apply those values you already have in your basic knowledge, and you just apply that to the other quadrants. So I'm going to focus more on this first quadrant so we can get a basis of the values of sine and cosine using the unit circle. So starting off, when we're looking at the unit circle, we have an x-axis and a y-axis, but the x-axis, we consider that the values of cosine x. So it's going to represent cosine x. The x values are going to represent cosine x, and the y values are going to represent sine x. So we can look at it like that. And then when cosine of x is equal to pi over 6, the value we get for this is, so when cosine of x is pi over 6, cosine is radical 3 over 2. And when sine of x is pi over 6, the value for sine is 1/2. And when cosine of x is equal to 0 right here, so this right here, when cosine of x is equal to 0, the value of cosine is also, when the value of cosine is actually 1, which we see right here. And when sine of x is equal to 0, the value is equal to 0. The value of sine is equal to 0 right here. Now, moving on, when cosine of pi over 4 is equal to, right here, is equal to radical 2 over 2, and sine of pi over 4 is radical 2 over 2. Moving on to pi over 3, cosine of pi over 3 is 1/2, and sine of pi over 3 is radical 3 over 2. Now, same thing over here. When cosine of x, so cosine of x of pi over 2, so this y-axis right here is pi over 2. So cosine of pi over 2 is simply 0, since this is going to be on the y-axis. There's an intercept here where the x is equal to 0, x is equal to 0, and we already know that x is cosine, so cosine is equal to 0. And when sine of pi over 2 is simply 1, since we have it right here. So we can just rewrite that. So it's going to be 0, 1. So those are the basic values using the unit circle for sine and cosine. But usually you're gonna have to memorize a small table of values, and I'm gonna show you guys a little trick to actually write out that table of values, the table of values, and it makes it a lot easier to actually memorize. The unit circle can sometimes complicate things for beginners, but the unit circle is essential to understanding some of the topics in calculus. So I would recommend actually taking the time to draw out a unit circle and practice drawing out a unit circle and its values. But there's also a simpler way, and that's with a table of values. So I'm going to draw out a small table. So we're gonna have values of sine, and we're gonna have values of cosine in this table. So sine, cosine. So first I'm just gonna start with sine and cosine, and then I'm gonna move on to like tangent, secant, and all that kind of stuff. So starting off, the first value we have is 0, then it's pi over 6, then it's pi over 4, then pi over 3, and then pi over 2. So the little trick I've been doing is basically, you can write out for sine, you can just write out 1, 2, 3, 4, and 5. And for cosine, you can write the same thing, but backwards. So 5, 4, actually no, it starts from 0 to 4. So you go from 0 to 4. So 0, 1, 2, 3, 4. So for sine, 0, 1, 2, 3, 4. Cosine, we just write the opposite, 4, 3, 2, 1, and 0. So the first step we're going to do to find the values of sine and cosine, all we have to do is divide each of these. First we take the square root of each of these values. So just take the square root. So we take the square root of all of this. So for sine, the square root of 0 is just 0. So the value for sine right here is just simply 0. So the square root of 1 is just 1. So we're gonna write 1, but that's not the actual value of sine at pi over 6. But there's an extra step too. But for now, we're just gonna take the square roots first. So square root of 1 is 1, square root of 2 is a number, but we're gonna just leave it as square root of 2. So square root of 3, same thing, we're just gonna leave it as square root of 3. And square root of 4 is simply simply 2. Square root of 4 is just 2. Now, since we already did sine, we know some of the values already. So we can just write what we wrote on it for sine, and we can just do the opposite for cosine. So we can just write 2. We can leave the radical 3, we can leave the radical 2, and square root of 1 is just 1, square root of 0 is just 0. So now that we've gotten to this point, so what did we do first? First we wrote out the numbers 0, 1, 2, 3, and 4 for sine, and then we did the opposite for cosine. The next step we did was take the square root of each of those numbers, and that's what we did, and we end up at this point. Now, once we get to this point, we divide each of these values by the integer value of 2. So 0 divided by 2 is simply 0. So that is the value of sine. So when sine of 0 is equal to 0. Now, when we divide 1 by 2, we get 1/2. So when sine is pi over 6, the angle is pi over 6, sine of x is equal to 1/2. And when we divide radical 2 by 2, we get radical 2 over 2. So a sine of pi over 4 is radical 2 over 2. And then for pi over 3, we put this over 2, radical 3 over 2. And we get when sine of pi over 3 is equal to radical 3 over 2. And then we divide 2 by 2, and this is just simply the value of 1. So when sine of pi over 2 is basically equal to 1. And we do the same thing for cosine, and we end up with the same values but backwards. So 1, radical 3 over 2, radical 2 over 2, 1 or 1/2, and 0. So that's how we get the values of sine and cosine. So this is how we get the values of sine and cosine, and the unit circle basically diagrams the values of sine and cosine but using the unit circle. So in order to get the values for like tangent or cosecant, secant, or cotangent, we want to use what we went over in the basic trig functions video. We want to use the way the rewritten ways of how we related each trig function to their counterparts or other trig functions. So in order to get the values of, say, let's say tangent, let's start with tangent and then move on to the other ones. So I'm just gonna copy this table so I know how to redraw it. So this is gonna be tangent of x. So this is tangent of x, and we know that tangent of x is simply sine x over cosine x, which we said over here. So we can use those values of sine and cosine we already figured out and actually calculate the value for tangent. So when tangent of 0, when we have tangent and the angle is 0, we look at when sine and cosine are 0. So when sine of 0 is basically equal to 0, cosine of 0 is equal to 1. And we know that sine tangent is simply sine over cosine. So 0 over 1 is 0. So tangent of 0 is equal to 0. Now we do the same thing for pi over 6. When sine of pi over 6 is equal to 1/2, cosine of pi over 6 is equal to radical 3 over 2. So we get this. We get this 1/2 over radical 3 over 2. This radical 3 over 2 flips up. This 1/2 comes down. This denominator of 2 comes down, and we get a value of radical 3 so wait, I think I made a small mistake. Hold on. So when we do this, it's going to be 1/2 over radical 3 over 2. This radical 3 over 2 flips up. 2 comes down to the denominator, and we get a value of radical 3. So when tangent of pi over 6 is basically equal to radical 3. Now we look at the angle of pi over 4. Pi over 4, when sine of pi over 4 is radical 2 over 2, cosine of pi over 4 is radical 2 over 2. So we're going to have radical 2 over 2 over radical 2 over 2. This denominator flips up. This denominator right here comes down. And here we get a value of 1. So tangent of pi over 4 is equal to simply 1. For pi over 3, we do the same thing. Sine of pi over 3 is radical 3 over 2. Cosine of pi over 3 is 1/2. So we do the same thing here. Radical 3 over 2 over 1/2. But over here we get a value of this flips up and this flips down. So we get radical. So we get radical 3 right here. We get radical 3 over here. And actually, pi over 6 right here, pi over 6 should be radical 3 over 3. And that's because when we actually flip these around, we get we get a radical in the denominator. So we have to find the conjugate of this radical, so we can make it we can make it in a more simpler form. So the conjugate of this is just simply radical 3 over radical 3, and this is just radical 3 over 3. Radical 3 over 3. So the value of tangent at pi over 6 is radical 3 over 3. Now for pi over 2, we go back to that table of sine and cosine. Sine of pi over 2 is 1, cosine of pi over 2 is 0. So we have 1 over 0. And 1 over 0 is actually not 0, it's an undefined number. So at tangent is undefined at pi over 2. That means that tangent has a asymptote at 1 over 2. And we can see that by looking at its the graph of tangent. So the graph of tangent looks something like this. Let me make this a darker color. the graph of tangent looks something like this. It looks like that, and has asymptotes at pi over 2 and negative pi over 2. So there's asymptotes right here. That's why it's undefined there. There's no value, there's no specific value at pi over 2 that can be written for tangent. So we just say that tangent is undefined at pi over 2. Now moving on, we can go into the other function, cosecant and secant and cotangent. So let's start with cosecant x. Cosecant x. So we know that cosecant x, based off the basic trig functions, we know that cosecant x can be rewritten as 1 over sine x. So we're gonna apply that same thing right now. So I'll just put this in parentheses, 1 over sine x. So let's do the same thing we did with tangent, but instead we use 1 over sine x. So when sine of x is equal to 0, sine is equal to 0. When the sine for the angle of 0, sine is equal to 0. So 1 over 0 here once again is undefined. That means that at the value of 0, at the angle of 0, cosecant is undefined. Now when sine when at the angle pi over 6 right here, sine is equal to 1/2. So all we simply have to do is do 1 over 1/2, and this gives us a value of 2. So a cosecant at pi over 6, cosecant is equal to 2. So undefined and 2. Let me underline these values as well. Now at pi over 4, sine is equal to radical 2 over 2. So we just simply put 1 over radical 2 over 2, and we get the value we get here is 2 over radical 2. But remember, we want to make this in a more simpler form, so we want to multiply this by its conjugate, and we get a value of 2 radical 2 over 2. The 2's cancel and we're left with radical 2. So at pi over 4, cosecant is simply radical 2. Now for pi over 3, sine of pi over 3 is radical 3 over 2. So we plug in that value for 1 over sine x. So 1 over radical 3 over 2 is equal to it's equal to 2 over radical 3. And once again, we multiply by its conjugate in order to make it in a more simpler form. So we get 2 radical 3 over 3. And that's our value for, this is our value for cosecant at the angle pi over 3. So this right here. And now at pi over 2, we know that at pi over 2, sine is equal to 1. Sine is equal to 1, so 1 over 1 is simply 1. So at the angle of pi over 2, cosecant x is equal to 1. Now moving on to secant x. Secant x, we can look back at the 6 basic trig functions. Secant x is simply 1 over cosine x, and similar to how we figured out the values for cosecant x, we can figure out the values of 1 for secant x. So cosine x. So at 0, at the angle of 0, cosine x is equal to 1. is equal to 1. So simply 1 over 1 is 1. And so that says that at the angle of 0, secant x is equal to 1. Now pi over 6, cosine of pi over 6 is radical 3 over 2. So all we simply do is 1 over radical 3 over 2. And we get a value of 2 over radical 3. We multiply by its conjugate, and we get a value of 2 radical 3 over 3. Now, for pi over 4, cosine of pi over 4 is radical 2 over 2. And we can simply plug that in to the rewritten version of secant, which is 1 over cosine x. So 1 over radical 2 over 2 is 2 radical 2, 2 over radical 2. And we can multiply by its conjugate and get the value of radical 2. So at the angle of pi over 4, secant x is equal to radical 2. Now at the angle of pi over 3, cosine of x is equal to 1/2. And so we plug that in to the rewritten version of secant x. So it's 1 over 1/2. The 1/2 flips up, we get a value of 2. So at pi over 3, the value for secant x is 2. Now at pi over 2, cosine of x is equal to 0. It's equal to 0. So when we plug that in to the rewritten version of the secant x, so it's 1 over 0. And we know that anything over 0 is undefined. So at pi over 2, secant of x is actually undefined. Now moving on to the last trig function. So far we went over sine, we went over cosine, we went over tangent, we went over cosecant, and we went over secant. Now the last function that's left is cotangent. So cotangent of x, if you look back at the 6 basic trig functions, cotangent of x is actually cosine of x over sine x, or it can be rewritten as 1 over tangent x. So what we're going to do is actually use this version right here, 1 over tangent x, to actually figure out the values for cotangent x. So let's actually do that. But you could use the cosine x over sine x as well, but I feel like the 1 over tangent x is a lot faster, since we already have values for tangent. Because if you use the cosine x over sine x to figure out the values for cotangent x, we're going to have to figure out both values of sine and cosine, which is double the work. So you always want to try to make sure you find the simplest way to do a problem, and this I consider is the simplest way to actually find the values for cotangent, using the table of values in the unit circle. So we're going to be using 1 over tangent x. So tangent of 0 is 0. Tangent of 0 is 0. So that means that we're going to have 1 over 0. We know that's undefined. So cotangent of x at 0 is undefined. Now tangent of pi over 6 is right here we see is radical 3 over 3. So we're going to have 1 over radical 3 over 3. And we get 3 over radical 3, but when we multiply by its conjugate, we get 3 radical 3 over 3. 3's cancel, and we're left with radical 3. So at pi over 6, cotangent of x is equal to radical 3. Now, at pi over 4, cotangent of x, at pi over 4, tangent of x is actually equal to 1. It's equal to 1, so 1 over 1 is 1. So at pi over 4, cotangent of x is equal to 1. Now for pi over 3, tangent of x at pi over 3 is equal to radical 3. So when we plug this in, 1 over radical 3, we get this, but remember we have to multiply by its conjugate to make it in a more simpler form. So we get radical 3 over 3. So for the value, so at pi over 3, the value for cotangent of x is simply radical 3 over 3. And at tangent at pi over 2 is undefined. It's undefined. So for pi over 2, we're gonna have to use the other way to actually find the values for cotangent, which is cosine of x over sine x. So first we're gonna have to find the value of cosine at pi over 2, then the value of sine at pi over 2, and divide them. So let's write that out. So cosine of pi over 2 is 0. Sine of pi over 2 is 1. So we know by definition, so I'm going to write that here too. Cosine x over sine x. We know by relation, cotangent of x is equal to cosine of x over sine x. Now that we figured out the values for cosine and sine at pi over 2, we can plug it in to this, and we simply get 0 over 1, and that is 0. That's 0. So now that we have the value for right here, which is cosine over sine. That is the value of cotangent of x. So that's the value of cotangent of x. So it's simply 0 over 1, which is 0. So at pi over 2, at the angle pi over 2, cotangent of x is equal to 0. And I'm going to make this table a little neater. So there we go. I made it a little neater. If you guys want to screenshot this in order so you have it in your notes or something. But these are the values of sine, and these are the values of sine, cosine, tangent, cosecant, secant, and cotangent, using the unit circle and a little method,